The diagram shows a river which is 120 meters wide and is flowing at 4 meters per second. Points A and B are on opposite sides of the river such that B is 50 meters downstream from A. A man needs to cross the river from A to B, so he's going in this direction, in a boat which can travel at 5 meters per second in still water. Shows a man must point his boat upstream at an angle approximately 65 degrees to the bank. Okay, so he's going to aim in this sort of direction. That's the bank. He's aiming down here, and his boat can do 5 meters per second. We know that this is 4 meters per second this way. And then he wants to head in this sort of direction, so we need this to be the resultant. Now, we can actually work out this angle here. So let's do that. And that angle there would be the same as this one here. And we know that this is 120 and this one's 50. So let's call that theta. So tan theta is 120 over 50. So theta is going to be the inverse tangent. Just going to check my calculator mode. Just make sure it's in degrees. And so we need the inverse tangent of 120 over 50. And that's going to be 67.38 degrees. And of course, this angle here is also theta because we've got Z angles just there. Okay, so, well, we can certainly work out this angle here, which I'll call phi, using the sine rule. So sine phi over 4 would be equal to the sine of 67.38 divided by 5. So sine phi is going to be 4 times sine 67.38 over 5. And from there we can find phi. So we want the inverse sine of 4 times sine 67.38 divided by 5, and that gives me 47.60. And so the angle that we're actually after, which is this one, that's going to be 180, take away 47.60, take away 67.38. So we've got 180, take away 47.6, take away 67.38, and that's 65.02 degrees. Oh. Which is showing that. That was only 4 marks, so I don't know if I've not gone a good way about it, but sometimes you just have to go the way you see. Find the time that man takes to cross the river from A to B. So we'd like to know the length of this side, because at the end of the day he's going 120 and 50, and we can use Pythagoras' theorem there to work out the distance he goes. But actually I can see it's a 5, 12, 13 triangle, so that's going to be 130 meters. And you could, of course, use Pythagoras to find that. So we need the third side of this triangle, which I'm going to call V. Okay, so how might we go about finding V? Well, this angle here is equal to alpha, which is the 65.02. So I can now say that V over sine of 65.02 equals, and I'm going to use the 5 and the theta, so it will be 5 over the sine of 67.38. So V is going to be 5 times the sine of 65.02 over the sine of 67.38. So we've got 5 multiplied by sine 65.02. Oh. And we'll divide that by the sine of 67.38. And that's 4.9099. So I'll say 4.91, and that would be meters per second to 2 decimal places. And so the time taken is just going to be that divided by that. The distance divided by the speed. So we've got 130 divided by my last answer. And that's 26.5 seconds. Correct to 1 decimal place.